not too loud on for those of you in the room.
You're not coming to this. Oh, yeah, you're not.
How about now?
No, I don't think it's on.
How about now?
No.
For anyone on Zoom, am I coming through?
I can hear you, but
Nope.
but no visual.
You guys could hear Rick? And Rick, you can hear me okay?
Yeah. I can
Okay.
hear you. So,
Yeah, we can.
We're gonna run with it.
Fine.
I can talk loud enough. We'll see if we can't figure this out as the day goes on. Come on in, Amanda. Zoom can hear me, but I'm not coming through locally here, but we're gonna sort that out just fine. So, welcome everyone. Welcome to the 2022 Solar Decathlon Design Challenge final event. This is our 20th anniversary as well. So that's amazing, 20 years ago. That means students that participated 20 years ago are at least my age. That's kind of crazy. But welcome. And for those that are joining us virtually, hopefully you can hear me just fine. Please send some chats right now. This is kind of just a basic intro, trying to sort out all the audio things. So please let us know if you're having any audio issues, if I'm not coming through clearly, send chats and we'll try to sort that out before we get to all the presentations later. Let's see how many things we can, how much of the technology won't work now that we've started. Ask the question again.
Well, should you guys put it in the chat in case they can't hear you?
I'm saying they can hear us.
Okay.
Unless that's changed.
Okay, we're gonna keep pressing on. We'll see how many other technical issues we can have. We're gonna have in the first 15 minutes and then the rest of the day is gonna be great. All right, so just high level agenda for the 2-day event. I know you all have this information, hopefully. Maybe you've downloaded the Whova app. I haven't, so if you have questions, ask somebody else that has. Is this just hopping along? So today we have presentations all day. We have a lunch break. Lunch will be served at the cafeteria or the cafe. So if anybody came and had breakfast this morning, it's in the same location. We also have a couple 10-minute breaks that'll occur in between different groups of student presentations. There for students, after we get through all the presentations today, at 4 p.m., there's a networking opportunity for our jurors that are both present as well as remote. That will be when we do deliberations. And then all right, this is why we have this 15-minute buffer. Is audio back for those attending virtually? Sweet. Thanks, Max. Okay, where was I? So this is the high-level agenda for tomorrow. Again, more details can be found in the Whova app. They're not all listed here. If you have any questions, feel free to come ask any of us in the management team during breaks. There'll be plenty of opportunity to do so. Basic housekeeping rules. Some of these are new because here we are on site. I've been saying the virtual housekeeping rules now for 2.5 years, but let's do our best. Let's keep our cell phones silent. In the event we have any sort of fire alarm or other weather emergency, we are in Colorado. You never know. Just turn to me. Okay, I will help get us where we're supposed to go in the event anything like that happens. Some other basics: restrooms. I said to most of you just down the hall to your left. But yes, I will serve as your NREL host to help guide us where we need to go in the event of any safety issue. Last safety reminder, for students that are going to come up here and present, you will eventually see that there is a lot of wires over here. I would ask that you don't walk over there. let me be the one to walk over there and trip over things and ruin the technology. There should be plenty of space up here for you to safely navigate for all your team members. I've also put a table here as an additional obstacle to further deter you, but it's just a friendly safety reminder. And then for those joining us virtually, you're probably sick of hearing this, but please remain muted. If you're not speaking or it's not your opportunity to present, we will make sure we do audio, video, sound checks, cameras well ahead of each student presentation so that we make sure that's all working. And in addition, we will go through the exercise of giving you control over the slides and make sure that that remote access is working. Okay. Now I'd like to introduce our jurors, which we actually have 4. 4 joining us today. So I'm going to read a few of their short bios, and then I'm actually going to have our 4th juror introduce himself. Oh, you think I can read that? I could try. Okay, well,
We
let's
can
start
try.
with you. All right. We had an old bio written up for one of our jurors, so I didn't want to read it. Okay, so first and foremost, I'd like to introduce Sam Petty. So Sam, he currently serves as the Commercial Buildings Integration Technology Manager and Efficient and Healthy Schools Campaign for the Efficient and Healthy Schools Campaign. Sam has been supporting the Department of Energy in the Building Technology Office, or we'll hear us say BTO all the time, for several years now. In the past, he worked with BTO as a contractor and an ORISE Science and Technology Fellow, Science and Technology Policy Fellow. His past work at BTO included supporting emerging technologies, the emergency technologies technology to market, opaque envelope windows, and HVAC and R, which is heating, ventilating, air conditioning, and refrigeration, for those that don't like these acronyms, portfolios. Sam received his bachelor's. Oh, this is fun. Thumbs up. Sam received his bachelor's in mechanical engineering from the University of Colorado in Denver. Prior to joining BTO, he has worked in the coal-fired steam generation industry, specifically mitigating mercury emissions, as well as precast modular construction. So let's give a warm welcome to those here, to Sam. And thank you for. And for those that heard that buzzer, I apologize. We're still sorting out some fun technology glitches here this morning. Second, I'd like to introduce Shannon Oliver. So Shannon Oliver is also up here at the front table. So Shannon holds a bachelor's degree in environmental health from Colorado State University and a master's degree in global environmental health from Emory University. His professional experience includes 8 years of environmental and regulatory compliance for the oil and gas industry, and more than 3 years as an energy and sustainability manager in the K-12 sector here in Colorado. Shannon's recent work, his recent work focus has included energy use analysis, as well as his energy tracking, climate inventories, and water conservation. A key project for his school district was opening a brand new K-8 school that is net zero energy ready. And it has a target energy use, or EUI, for those students who've been doing this a lot now, of roughly 26 kBTUs per square foot per year. So welcome, Shannon. Thank you for being here. Is audio still working? Okay, great. Thought I'd ask. Okay, next we have Nicole Peterson joining us. She's also up here at the front for everyone that's in the room. So Nicole is a senior project engineer with Thornton Tomasetti Sustainability Practice, where she integrates engineering and environmental design into every project with her balance of analytical and creative perspectives. Nicole has academic and consulting expertise in building performance analysis with specialties in daylighting, facade optimization, building science, thermal comfort, water, and operational and embodied energy. Prior to her current position, she worked at Teller Tan in New York City and the University of Washington's Integrated Design Lab at the Bullitt Center in Seattle, while pursuing a Master's of Science in Architecture, Design, Computing with a focus in daylighting. She holds a bachelor's degree from the Pennsylvania State University in Mechanical Engineering, Spanish, and International Studies. So welcome, Nicole. And our final judge is joining us virtually. Is there any way
We can't seem to get him spotlit.
Okay.
Let me try
We'll
again.
sort that out as we're going, but I'd like to introduce our fourth judge. He is joining us virtually. His name is Rick Osbow. So Rick has more than 40 years of experience in innovative, low-energy HVAC system design. A considerable amount of his career was spent as Director of Advanced Energy Technology for the RMH Group in Colorado. He designed the Golden Hill Energy Center in collaboration with the Solar Energy Research Institute, now known as ENROC, in 1983, and it was a prototype for energy efficient design. And he was awarded the ASHRAE highest honors for energy efficiency in the international competition of 1988. Now, more recently, he designed a cooling retrofit at the National Snow and Ice Data Center, reducing the cooling energy consumption by more than 90%. Rick has returned to his mechanical engineering alma mater, where he designed the remodel of the University of Colorado Boulder's Recreation Center, the first recreation center to receive LEED Platinum certification in the country. Rick has dedicated, this type is so small for me, so I apologize, everyone. Rick has dedicated his career to high performance, energy efficient design, including commercial construction, higher education. This includes building design, specific projects, commercial construction, higher education, hospitals, central plants, data centers, and many more. So, final warm welcome to our fourth juror, Rick. Okay. Set these down. That was fun exercise. So I hope that we did just get through all the fun technical glitches of the morning. It is now time to bring up our first team. So I'm going to ask that our team from Shiraz University, if you are online, please begin coming off of mute so that we can do some audio, video checks. And I'm going to work to start pulling up your slides. So you go ahead and unmute yourself and so we can do that audio check.
Hello, can you hear me?
Yes, we can hear you. How many students are we expecting as part of your presentation?
The presenters are 3 people, including I myself, Ruzbek Imani, and Shirin Anwar.
Which student?
And,
Oh, go ahead.
and if it's possible, please give the access to Nafisa Kahe.
Can you say that name again? Sorry, our audio is breaking up a little bit.
Can you hear me?
Yes.
Could you please give access to me to control the slides? My
Yes.
name is Nafise Kahe.
Oh, sorry, say your name again.
Nafise Kahe.
AFISE. NAFIS. N as in Nancy. Sorry.
I can spell it for you. NAFISE.
Can you do me a favor? Can you try to request control from your Zoom?
Let me check.
Because finding you on here is not working. See if that works.
I'm not seeing it.
I sent you my request. So,
Should come through now. The way we'll test this, is that you advancing the slides? Excellent. Okay, all right. Before we get started, I'll remind all of our student teams as well as our jurors kind of the order of operations here. Each student team will have 8 minutes for their presentation. Of course, we will do those 8 minutes based on once we have everything set up and not the agenda you have in front of you. We will give a 2-minute warning. We'll give a 2-minute warning for those in the room using these color cards that Amanda has in her hand. And for those that are joining on screen, we will be switching the background that is for the camera that's on me right now to give a virtual 2-minute warning. And then we will cut any presentation off right at the 8 minutes if we have to do so. Immediately following your 8-minute presentations, there's 15 minutes of Q&A with our 4 jurors. Okay, so that's a little different from the last time we did presentations. And then we'll have some transition time between teams. So with that, I'm going to come back around since this is a virtual presentation. Jurors, do we have any questions from you? And that includes Rick. Do you have any questions before we get going for the day?
no, I don't. So,
Are we good? Okay. So to our team from Shiraz University, which welcome. That is quite a long way from where we are today. So welcome. Are you guys ready to start your presentation?
Yes.
Okay. So the floor is yours. We will start the 8-minute timer as soon as you guys begin. Good luck.
Hello, can you hear me?
Yes.
So, firstly, we would like to express our gratitude for the opportunity to present in such an educative context. Today, we'll introduce our project site and city, then we will present our design constraint and CSA. We proceed with our design goals, strategies, and our PDE. Danishgah School is located in Shiraz, a city full of beautiful gardens and old schools. Accordingly, we wanted to integrate that image into our design. Danishgah, as our retrofit project, is a single-gender school and 1-story concrete cuboid located in a 2-acre campus. School authorities want us to use the National Green School Rating System and its GTS Plus green level. While planning, we face 5 main design constraints. Metaphorically, we find confronting the project as tackling with an unsolved Rubik. To start our journey, we plan a timeline beginning with an on-site survey and ending with a POE. Each milestone is meticulously planned. To solve our Rubik and assure different school issues to be addressed, we've developed a systematic design process in 4 phases. To better respond to the context, we've investigated environmental factors using multimodal analysis and gridding technique. The students' behaviors were also visualized using a drone and video processing technique in Python, and simulated in depth map and PetSim Pro using space syntax and agent-based modeling. School design influences students' thermal comfort, hence it was modeled in MVMet. Finally, PET and PMV at various metabolism rates were estimated. To see how students represent school internally, cognitive data were collected from survey students. Using VR eye tracker, the areas of interest were also visualized. Survey students' mental, emotional, and physiological conditions were examined to study their school-related experiences. Our Harvard colleague advisor helped us interpret the results. To measure energy and lighting conditions, our Studio Energy Plus and Dialogs were used. Due to the school's unsustainable qualities, the results show substantial air infiltration, excessive power, and energy usage. Our CSA gave us more in-depth understanding of both the school and the schoolers, considering the addition of multidisciplinary studies.
Based on our CSA, we have developed our main design strategies. These strategies are in line with our National Green Rating System 7 criteria. Here you can see those strategies are reflected in our retrofit plan under the competition 9 design contest. They range from improving energy performance to enhancing student well-being. This is our retrofit design proposal, a much higher performance school with several sustainable features and attractive spaces. The school is replanted where necessary. To improve our school performance, various low-efficient zones were removed and multifunctional spaces were added or relocated. In our suggested plan, roughly 70% of existing walls are maintained with the addition of a second floor to embrace needed areas. That includes learning corridors, brown roofs, and multipurpose rooms. These are our school facades. To be climate responsive, several facade components, including shaders and light shade, are added. This section describes various school spaces, their purpose, and circulation patterns. This is the school's main entrance with a colorful yard to invite students in. A convenient access bike rack with a solar panel is designed to encourage cycling. The schoolyard is designed to encourage students to be explorative and creative. Growing and eating healthy food is taught in our edible garden. The biotop garden is an urban wildlife oasis to teach kids about sustainable ecosystem. For us, green schools are about educating our world's future thinkers and builders, not only saving energy and water. The atrium, the school living heart, and the new home for our lovely tree of knowledge embodies this concept. Classrooms are the school's educational course. So different design strategies such as indoor-outdoor integration have been suggested to provide an appealing learning environment for a student. The current structure is concrete, beam, and column. Considering the structure constraint, the sustainable LSF structure and K+4 were proposed for the expanded first floor. Strategies to promote passive system include design a sun space, a skylight, light shaders, and shelves. High-performance active and HVAC system are also suggested. We collected rainwater from roofs and sent it to a tank. It is later fed into a flushing toilet, rain gardens, or a heater tank.
For market analysis, different financial studies have been conducted. Using RS means and WBS data, the school's retrofit costs, its NPV and IRR over 10 years were calculated as shown here. Here, several sustainable approaches to decrease buildings operation and maintenance costs and boost school income are proposed. Our design incorporates resiliency strategies. This is most evident in our landscaping, where we study ways to promote biodiversity and lessen anthropogenic stress.
I guess we have technical issues here.
Okay, pause for a second. Hopefully you can hear me, right?
Yes, I can hear you. Can you hear me?
Yes.
There were two mics live for them,
Okay.
but it looks like one's on mute now.
Are your guys' mics working again now as expected?
I think it works, but I can't change the slides.
Oh, okay, give me just a second. Don't worry, we've paused the timer. Let's see, are you able to, it says that you're controlling the screen. So if you click on the screen and give us your mouse, does that work?
Sorry, I can't hear you clearly.
Is it better right here?
Yes.
Okay. It says that you do still have control of the screen. Can you try clicking your mouse into the Zoom screen and then advancing slides again to see if that works?
Sure, I'm clicking, but nothing's changed.
All right, give me a second then. Is there a way for you to request control again?
Let me try. No, it's not working for me.
Megan? Are you guys using your keyboard to attempt to advance? It says you have control of the screen, so.
Yes, I'm using my keyboard, but unfortunately it's not working.
Let's just do this for a quick second.
بذار
الان بزن دوباره رفرش کنم.
Okay, now can you request, request control again?
Let me check for a second. Sorry, could you give access to Shirin? SHIRIN.
Is there a way you can request it? Because like you did before, I think you requested control.
Let me, I'm sending you my request.
Okay. All right, I approved it.
Let me check if it is working. It's not working again.
And you're using a keyboard.
Yes, I'm using my keyboard and my mouse, but nothing changed.
Okay, is it possible for you guys to just tell me to advance to the next slide?
Nothing changed. Could you give access to Shirin?
Whoever that is will need to request access the same way you
Yeah.
did.
Okay. I'm going to send the request. Just a second, please.
Yep.
It's gotta be like 1 a.m. or something, right? Yeah. Two p.m. Oh.
Excuse me, is it possible to give access to Shirin Anape because she doesn't have any request button to press and send a request?
Do that. Yeah, how do I give them? Right here. I can't give them control that way. That's, yeah, we can't give control that way. Can you guys, so I know your slides are relatively timed. Oh, wait.
Okay,
Somebody-
I have refreshed everything. I'm again sending my
Okay.
request to you.
Okay. Yep, give me just a second though, because I have other things pulled up on my screen.
Sure.
Okay. Can you attempt to take back control or attempt to move the slides again? Is that working?
I think it's
Okay.
working. Let me check again.
Okay, looks like it's working. So just, so you know, get to the slide that you guys were on. There's roughly 2 minutes and 30 seconds left on your timer.
Okay, just a second, please.
Not sure I did anything. Okay, is this the slide you guys are ready to start on?
Yes, yes, we are ready.
As soon as you start, we will start the timer again. Just as a reminder, you have roughly 2.5 minutes left. Start whenever you're ready.
Okay. For market analysis, different financial studies have been conducted. Using RS means and WBS data, the school's retrofit costs, its NPV and IRR over 10 years were calculated as shown here. Here are several sustainable approaches to decrease buildings operation and maintenance costs and boosting school income are proposed. Our design incorporates resiliency strategies. This is most evident in our landscaping, where we study ways to promote biodiversity and lessen anthropogenic stress. Our strategies to reduce embodied environmental impacts include using locally sourced materials and products, decreasing the carbon impact, and optimizing energy use. Diverse architectural and engineering design solutions are integrated to meet both environmental and aesthetic values. The atrium, for example, can collect solar energy in the winter and release it in the summer, causing air circulation. To assess the impact of our retrofit, sound, thermal, visual, and air quality have been analyzed before and after our design. Overall, our data shows significant improvements. Several energy reduction strategies, such as modifying the building form, increasing thermal insulation, double glazing windows, were all investigated using Open Studio. The design school EUI is 33 kilowatts per cubic meter, roughly half of our target. Climate Studio was used to calculate ASE and SDA. It provides us where the DA exceeds thresholds. Our national lighting design strategies improve school day lighting condition by 80% SDA and 4.4% ASE, according to simulation results. As an example, southern windows were designed with a light niche and a horizontal canopy to receive efficient daylighting. Due to our analysis, these reduced the direct sunlight intensity. Artificial lighting was also simulated, visualized, and optimized using Dialux Evo. Finally, we compared our lighting design outputs with our national lighting standard to assure its efficiency. Solar panels with calculated diameters and orientations not only met our school's energy needs, but also generate additional energy to feed back into grid and used by neighbors. Because we value our user experience, we conducted a post-design evaluation to assess the benefits our retrofit will provide for students. For PDE, our 3D VR model was streamed for students, and brain mapping and eye tracking were also used to study their emotional and perceptual conditions. And these are examples of students' reactions to our design. One illustration shows how students find it wonderful that a narrow, darker space used by seniors to bully others is turned to a lively education yard. And this was how we tried to solve our Rubik. And we think it's a good start for having a greener school, smarter students, and a brighter future. And finally, we would like to thank all our advisors, partners, and mentors for their great contribution. It's finished.
Thank you. Thank you. Thank you, guys. And thanks for dealing with that major hiccup in the middle. I'm glad we actually got to your last slide. So it really wasn't an interruption. So round of applause for everyone in here. Okay. Again, students, thank you for your patience as we work through that. Now we have 15 minutes. Now we have 15 minutes of Q&A, which will be now. So feel free to ask questions that include Rick, and we'll try to sort out any issues for students who are potentially in the same room together with multiple mics, but you have to mute unless you are speaking. Okay, so let's begin the Q&A.
In the name you.
Do you want us to go to the mic?
No, you should be
Okay.
able to just.
That's it. Another. Hope I know.
Hey, this is Shannon Oliver here. Can you guys hear me on the online? Okay, wonderful. Thank you guys. Great presentation. Nice job navigating the tech difficulties. I thought your engagement was very innovative. I'd be interested to know kind of how you came to that process using the VR and eye movement, and sort of why you guys wanted to use that process for your engagement on the planning side. You're muted if you're responding.
You know, in our retrofit design, we try to have a whole process in our designing, and because of that, we try to use our CSA, I mean, comprehensive site assessments and other things that we try to have a whole study in our retrofit design.
Awesome. Thank you, guys.
And also our other studies, including our neuro architecture and including these things.
I have a follow-up question to Shannon. This is Nicole Peterson. Great job and wonderful renderings. They were beautiful. But in regards to the CSA, the multimodal process, I was just curious. I would have loved to hear a little bit more about how the vertical and the horizontal ended up coming together and like what your key findings were from that. Did you have a couple key findings that you could share with us that you feel like were really drove the design forward, that kind of changed something in how you ended up designing?
I think you guys are muted if you're responding. We can't hear you.
Yes, you know, as we have in our design narrative, we've got a part in our design narrative, which is what we learned from the CSA. In that study, we understand from our surveys and also our different maps that was surveyed from our school, we understand that, for example, where we have where the students are getting bullied or something like this, and then we try to retrofit our design and our concepts to these ideas.
Thank you. If perhaps an easier question, but just curious if you thought about when you touched on it in your design narrative, moving the tree into the atrium. I was curious if you thought about the survivability of that and if you studied whether that would actually survive. It's a great idea, but just curious.
You know, as one of our advisors are Ehrenfeld Heritage Garden, and in there we have numbers of expert engineers that work on landscape architecture, and you know, with advisors from there, we try to save our tree because it didn't get you know, sufficient daylight, and we try to move it into a better place, and also a better place for a tree itself, and also students can really enjoy that place, which it's the atrium.
Thank you.
Hey, Rick, I think you just muted yourself if you're trying to ask a question.
Yeah. So my question was, is this a actual or a theoretical project? Are they going to go forward with construction based on some of your recommendations? And also you had a very brief description of the mechanical system as being a boiler and a chiller. But what kind of terminal systems, or what kind of air handler or UFAD did you use for your actual HVAC distribution? And one more question is on your cost estimate. You had $3.41 for mechanical. That's pretty low, but I was just wondering how you developed your cost estimates. Thanks.
Students, if you're speaking, you might be muted again. Oh, there we
Sorry
hear.
to, can you hear me? I'm so sorry.
Oh, it's okay. We can hear you now.
Okay, to tell you about your first question, you know, this study was started in 2018. It's a real study, and it was because of the pandemic situation. It stopped in 2018, and we hope that we start to continue this process in the next year with the school, and try to design and build a better place for them.
Did you happen to hear my additional couple of questions if we have time?
Yes, we have 5 minutes. Students, did you hear Rick's second and third question? Rick, perhaps maybe a quick repeat.
Yes.
No, unfortunately, we had some internet problems. Could you please repeat it again?
Yeah, on your description for mechanical systems, all you had was that you had a boiler and a chiller. But what kind of systems, HVAC systems, did you model on your energy analysis? And how did you do your cost estimates? Some of them seem a little low, but like $3.41 for HVAC. I was just curious on how you developed your cost estimates.
You know, our cost estimate is based on our current economic, which is in Iran. And, you know, for our schools, we have some of our discounts. It goes for some of our mechanical systems and green schools. And based on that, we have estimated this cost because it's our discount.
And do you happen to know what kind of HVAC systems that you were planning on?
About mechanical system, with consulting advisor gives us consulting advisor gives us this recommendation about choosing chiller and boiler. So we choose system that can be maintained and supplied by manufacturing in our country.
Okay, thank you.
You're welcome.
Jurors, there's time for a quick question if we still have one. That's my HVAC question, so, okay.
Just one quick one on you did a pretty good job, I think, on the consideration of water use, I think, for your climate. Did you guys look at like a water budget, annual water budget for kind of what you could capture versus, you know, what would be used, and see if those balanced out?
You know, based on our comprehensive market analysis, we have a cost payback from the start of the year, the 6th year, and we will pay back our costs in the start of our 6th year. Based on the IRR of 18%.
All right, thank you guys.
Well, fantastic. Well, thank you, Team 1 from Shiraz University, and thank you for joining us from so far from all the way around the world. So how about a quick round of applause for us here? The students, thank you again. Thanks for your patience. We will likely deal with technology issues throughout the day. That's okay. That's what I'm here to do. So for our second team from Thomas Jefferson, hopefully you guys are already on. If you are, please go ahead and begin turning on your cameras. Let's do a quick audio video check as I begin pulling up your slides. Okay. It's gonna be.
Hey Ryan, are we able to see? Are we able to see the presenters? Like, wow,
That's what we're trying to
Okay.
figure out.
Okay.
Yes, I know. That's,
Perfect.
we're trying to sort that out. There is a way. Yeah, just hang on that. For our team from Thomas Jefferson, I see Pauline, I see you. Paulina. Hi, Paulina. Can you unmute yourself and make sure we can hear you?
Yes, hello, can you hear me?
Yes. Fantastic. All right, give me just a minute. Okay, Paulina, do you know who would like to control the slides?
I believe Declan's gonna take control.
Okay.
Can you hear me?
So you should have the ability to request control. And as soon as you do that, I'll accept it. Great. Thank you, Declan. Give me just a second. I'm going to approve it. Okay, that's not me, so that appears to be you guys, correct?
Yes.
All right. How many presenters? Sorry, I should ask. We've got Paulina, Declan.
There will be 3 of us speaking today.
Can you hear me too?
Yes.
Can you hear me?
Yep.
Okay, cool.
Do we have all 3? Okay.
Yes.
Excellent. So give me just a second. I'm going to walk back around my desk. We're also going to try to make it so that the cameras of those presenting can come up on our screens as well. So that's what we're doing right now behind the scenes. So give me just a second. Okay. And so they're all up there and I know it'll now because it only shows 5. Okay. Okay, our Thomas Jefferson team, can you hear me? I just walked around to the other side of the desk, so I just want to make sure.
Yep.
Okay. Thank you all for joining us. You may have seen we ran into a few technical glitches along the way in our first presentation. That's okay. If we run into that, we'll pause and we will accommodate. So please do not sweat about that. As a reminder, you have 8 minutes and then we will have 15 minutes of Q&A. Can we just confirm one more time that the remote control is still working? Excellent.
It is working.
Fantastic. Thank you, Declan. Okay. Well, welcome. And let's go ahead and turn the floor over to our team from Thomas Jefferson University. We will start your 8-minute timer as soon as you guys can. So welcome and take it away.
Thanks for the opportunity to present today. We'll be representing Jefferson University's team in the educational division of the Solar Decathlon. This adaptive reuse of William D. Kelly is meant to foster a healthy learning environment at Kelly in a way that the benefits can be reaped by the immediate community through a welcoming experience that they may reclaim their identity and serve as a beacon for growth and change. William D. Kelly is a K-8 grade school located in the Brewerytown section of Philadelphia. Our team is made up of 6 Jefferson undergrads under the instruction of Max Seinheiser. The goals of this retrofit are to design a net positive building using multiple technical subsystems, preserve the identity of the community, generate a self-sustaining ecosystem within this urban context, promote healthy lifestyles, create adaptive learning spaces, enhance the occupant experience, and foster community integration.
This retrofit will benefit the student body made up of approximately 321 students of color, the 23 full-time faculty members, as well as the surrounding neighborhood of Sharswood. Due to the lack of accessible resources to this community, we have created a self-sustaining ecosystem and a fully functioning food system, among a number of other features meant to promote healthy lifestyles and enhance their overall quality of life. Our project is located in northern Philadelphia, Pennsylvania, located in climate zone 4, a mixed humid climate, and with an emphasis on plant growth, we needed to consider our plant hardiness zone of 7A. Due to a mixed climate and varying temperatures, we had to consider both heating and cooling. Air circulation and cloud coverage was also taken into account for energy production and fresh air ventilation throughout the design process. This is an overview of our proposed site. Being one of the largest buildings in a primarily residential area, we want to combat our site's impact on the heat island effect, which at times can be about 8 degrees hotter than the surrounding areas.
Starting off in our main building, we wanted to create a welcoming entrance with highlights to the food system by raising the ceiling height and opening up the space. The addition of a curtain wall to separate the lobby from the greenhouse not only creates visual connection, but brought daylight into the space. The library has been relocated to the middle of the first floor, taking advantage of a triple height space to illuminate the library and corridor. With such high ceilings, we integrated a number of acoustical systems to help dampen noise. This newly integrated food system was integral for the principal's vision of the school. The system will consist of a renovated cafeteria, a teaching kitchen, and a newly constructed greenhouse. Classrooms were designed to create optimal spaces for learning. To maximize flexibility, we have selected trapezoidal desks and furniture on casters. The comfort of the students was one of our top priorities, using acoustic clouds to help dampen noise within the classroom and daily responsive lighting to light the space. And across the street from the main building, we're proposing a new gymatorium. This space will be outfitted with flexible seating, rigging, and other systems to accommodate both the needs of a fully functioning auditorium and gym. Centrally located within the neighborhood, this gymatorium will serve as a space for the community to gather during after-school hours.
To help make the school look less institutional, we decided to clad the exterior of the building with vertically oriented wood slats and blue prefabricated metal panels that will match the murals below. Being a masonry building with no pre-existing insulation, there were a few challenges to overcome when trying to improve our thermal envelope and minimize thermal breaks. We've decided to demo any existing unpainted brick to be recycled and reused as much as possible throughout construction. We plan to insulate the first floor behind the mural and provide exterior SIPS panels around the entire perimeter of the building above.
The addition of the new skylight and punched out floors in the library will allow for natural light to enter deep into the hallways of the existing school. The classrooms will take advantage of new ERV units and operable glazing to help control temperature and cycle fresh, clean air throughout the space. The cafeteria will feature a new high-efficiency ground source heat pump that will be used to control temperature with a series of operable glazing, VRFs, ERVs, and ceiling fans that will cycle fresh, clean air throughout the space. South-facing glazing and a large storage area will act as an oversized light shelf to bounce diffused light deep into the space. We have turned the previous auditorium into an on-site greenhouse to support year-round growing of produce. The greenhouse incorporates cross-ventilation to promote circulation, radiant heating to heat the gardens from below, and an insulated blanket which may roll out at night. To help avoid the use of pesticides, we would introduce natural predators, which will be controlled with the addition of the ecosystem outside. The new gymatorium will take use of multiple passive strategies throughout its design. Incorporating horizontal louvers and a clear-story window with a deep overhang will help bounce natural light deep into the space while limiting any harsh glare. Its cross-ventilation and high R values will help minimize heating and cooling loads.
This diagram breaks down the project timeline into 4 phases: the e-building, food system, gym, and site work. The total cost of the entire project is expected to cost about $18.3 million and take 3 years to complete. The space frame is designed to be an interactive extension of the existing building that may help support the load of the PV panels while also controlling the amount of daylight that enters the building. The space frame is made up of operable mesh panels to diffuse light before entering the classrooms and denser vertical elements which provide support for greenery.
The design expresses a connection to the community through the creation of integrated programming such as a space to wash clothes and a food pantry. The outdoor space was designed to create a self-sustaining ecosystem within this urban context. The space uses rain gardens to help mitigate stormwater runoff, pollinator gardens to attract wildlife, in addition to butterfly, bird, and bat boxes.
Moving on to the energy performance of this building, we've estimated the existing building to have a rough EOI of 73 because of its oversized heating system and its lack of a central cooling system. After replacing these insufficient systems and adding the amount of energy we'll be generating from solar panels and wind turbines, we have greatly reduced the building's EOI to be around -7 for a net positive energy design. Our design uses approximately 1,000 PV panels. The energy collected will be stored in the gymatorium, and any excess power not used will be sent to the power grid to be used by others. For maximum efficiency and durability, we have chosen a model with no grid lines and solid metal backing.
To reduce our need for city water, we have implemented a strategic water system that will collect water from our site. Our water system is made up of a visual Rube Goldberg system, multiple on-site cisterns, a biofilter system for gray water, and a living machine to clean black water. Lockable valves will be provided for code compliance until superior water systems are allowed. Any overflow water will be used to mist and clean the solar panels. Energy demand can primarily be seen through the lighting and appliances. Producing more than 2 times the energy required, we are able to store power in the case of an emergency. The stored energy will be capable of powering lighting and refrigeration for up to 6.8 days and lasts even 8.2 days after cutbacks of lighting usage. Batteries are portable and may be transported offsite to assist the community when necessary.
Through this net positive retrofit, we've designed William D. Kelly to promote healthy lifestyles and improve the overall quality of life of Brewery Town, Sharswood, Philadelphia. Thank you for your time today.
Fantastic. Round of applause for everyone here. Thank you. Thank you, students from Thomas Jefferson. Okay, we'll transition now to our Q&A opportunity. I'll leave control over the slides, hopefully, just in case it's needed. But to our jurors, feel free to begin your Q&A.
Hey, morning, everyone. Shannon over here. Thanks again for your time. A nice presentation. I think I'd be interested to hear a little more context on the HVAC system choices. VRF and ERV are great. Can have a little bit of a higher front end cost. So just talk us through the process, how you guys kind of landed on the overall system design there.
Students, can you guys hear us?
Yeah, sorry. We chose these to filter clean air throughout the space and to reduce the need for an overall system that had to connect back to the basement. So we wanted to put these into the individual classrooms to control individually. And we didn't have the room for ducts.
Okay, thanks.
Yep, thank you.
Yeah, follow up to the HVAC. First of all, this is a question I'll probably ask everybody. So is this going to turn into a real project, or is this just a study or a theoretical? And so if you could answer that question, that'll lead into my next one.
Yeah, we've had a good amount of interaction with the school itself and the principal, Dr. Crystal Edwards. She's very interested in this design. We have a community presentation with her next week. And the hope is that eventually this can be built. She said that before she retired, she wanted to see this to fruition.
Just one comment. From an elementary school standpoint, I mean, the whole system was very well thought out and holistic, but like composting toilets, digesters, microturbines, wind turbines, batteries, that's kind of a real high maintenance and operation for an elementary school, even so probably for a college, but just a word of, just from an experience standpoint, that this will require probably a higher level of operation than they might think. So anyway, just my own personal opinion. So anyway, but it's well thought out. Thanks.
Can you all hear me if I don't lean into the mic? Yeah, okay, great. Yeah, great presentation. You had some really unique, creative ideas. Loved the Rube Goldberg water features. You went into color theory, so great job overall. Some unique ideas. A couple questions about the greenhouse. My first question is, I was wondering if there's any way that you're capturing, you're getting all that heat into the greenhouse. Wondering if there was any way, or if you considered using that heat for other areas of the building. My first question. And my second question is, was there any research done on the greenhouse and gardens of what kinds of food could grow?
So I'll take the second part of the question. We did extensive research into the produce. A lot of things that we were chosen could maximize the growing capacity. So lots of like lettuce, tomatoes, carrots, arugula, cabbage. Dr. Edwards was really passionate about creating the food on site and having this strong visual connection with the students. So this is like the main area for growing. And then we have the community gardens, which could also be used for the school and allow spots for the community to rent out.
Great, that's fantastic.
Going back to the HVAC system, just out of curiosity, you said you were going to use ground source heat pumps. Do you have a site plan or a siting for the ground source or boreholes or the overall field?
We plan to locate those ground source heat pumps within our, basically the main building site work. Since we're going to be replacing all that asphalt, we figured that'd be the most effective place for them, as we'll be doing a lot of groundwork there.
And then on the extra biogas turbines and wind turbines, have you guys done the cost benefit analysis to see if they will actually pay off for themselves, or if it's too much of an added cost to begin with, that it's maybe not worth it?
Yeah, unfortunately, we didn't get the chance to go too deep into that, but we have figured out that over time it should pay off. With about 3 turbines. We've carefully selected our type for this urban context within the city. So Eco Whisper turbines that could really work effectively and not be too loud within the community. And back to the question about the heat in the greenhouse, we're trying to capture as much as we can for preserving it for the winter, and then possibly using it throughout the kitchen and the cafeteria with the ERV units, because they're connected so closely together.
That's good to hear, because I was reading through and I felt like that would be a good opportunity. So I have another unrelated to energy question. The painted brick from the mural that you're going to repurpose, you said you're going to insulate behind it. And I was just curious if you considered the hygrothermal impact of that, of having, insulation be on the interior. You kind of change the wall assembly in that way. And so it was just, something good to consider in this climate zone. It's maybe not as critical. I'm actually from Allentown, so I know the climate pretty well. You don't necessarily have to deal as much with freeze thaw, but maybe mold growth issues. So just wondering if you thought about that.
Through our research, we found that with the masonry brick walls, this is done quite often, looking at other projects. But we didn't go too much into detail.
Good to think about in the future. It's always good to get materials tested. So, but it's a really great idea to repurpose that. Just wouldn't want to ruin the mural.
Thank you. Yeah, we believe that the community murals are a huge part of what makes the school. And they focus a lot on Black culture and significant people throughout history.
Great.
We still have about 5 or 6 minutes available to us jurors, but so feel free to ask an additional question or two.
I had one more question. So you had selected some wind turbines. So how high do they have to be? Are you going to have high towers, or did you do an analysis of the availability of appropriate wind on site?
Through our research, they have to be a 35 height minimum, but it's recommended to be about 60 feet.
Okay, thanks.
And yeah, we located them in the community area of the site, which has the least blocking from surrounding buildings and the most exposure to wind.
How many kW per turbine did you estimate? Yeah, maybe you don't know at this point, but that's all right. So,
I don't know off the top of my head, unfortunately. I'm sorry.
that's fine. Sorry.
Just a quick question on cost. I think you said the total project cost is around 18 million. I was looking, I couldn't find it. What did you guys end up at $1 per square foot? And is that competitive in your market, I guess?
Again, off the top of my head, I don't know how much it is per square foot, but we did get an estimate from a local contractor what it would take to renovate the school to be up to today's standards. And I believe that was about 30 to 40 million. And we have our budget about 18 to 20.
Yeah, that was kind of my guess too. It's more like 30. So it's a nice cheap project. It's good work.
Thank you.
I have a few daylight questions. It seems like you put a lot of thought into that. And so I would just like to hear a little bit more. I was curious about the space frame system. If you, so I have a few questions. If you did daylight analysis on that piece of it to understand the benefit, you said it would be beneficial. So just curious, how you arrived at the design for that. And I was also curious why you chose triple height glass for the library, and if you considered the glare concern there.
To speak on the glare part of the library, we do have windows on multiple sides as well as a skylight. So through our studies, we found that having different directional light, that kind of helps the glare a bit.
We really wanted to get that light deep into the corridors. So it was integral for us to create this space within the library. The library is centrally located to the building. So it gives us the opportunity to bring light into those corridors and really open up and liven the space.
And for the space frame system, did you guys do daylight analysis on it?
Yes, I believe. Go ahead, Declan.
Yeah, we did do a daylight analysis. I don't know. It should be showing up on the screen. I don't know why it's not here. It's at the end. But we did take into account like the daylight factor that would be coming in to like the gymatorium, making sure that like our overhangs aren't like too much, but also aren't too little. Create like, a nice natural light so that we don't have to use too many like, artificial lighting within the gym. We can mostly rely on the mostly rely on natural light to light up the space without any of the glare.
What's the control strategy for the louver system? Is it controllable by classroom or is it automated?
Yes, each classroom will have access. Well, every classroom that will have access to the space frame outdoors will be able to control each of the louvers from the space frame.
We looked at this as like a huge learning opportunity for the students. So teaching them the effects of, at one way, this angle, it's really bright in our room. So we're going to turn it the other way to make it a little bit darker because we're presenting on the TV today. So a lot of this was looked at in the educational aspect of it.
That's very creative, and yeah, that'll be a great learning experience.
Any last quick questions from our jurors? There's like a minute or so left in our allotted time.
I'll do one more daylight question then. In the cafe, I was just curious. I love the idea of the storage being used as like a big light shelf, and that's great, but it is quite a deep space. So I'm skeptical that you'll get light all the way at the back. I was curious if you considered the, integration with electric lighting, or if you ever considered skylights at one point on portions of it to make sure you fill the space.
The reason we didn't put any more skylights on this section was to maximize our solar panel arrangement. We did look into the distance of the storage, and it should bounce the light into the space properly. And we also get, since right past it is the greenhouse, and the greenhouse has a glass roof, it should bring a lot of light in through that, and the system, the curtain wall system that connects the two.
Love to see it in action and be proof drawn. Great, thanks.
Yeah.
Okay, well, fantastic. Thank you to Team 2 from Thomas Jefferson. Yes, round of applause. Okay, we have a 10-minute break right now, and I'm going to give us the full 10-minute break. Be in front of the mic as well. Okay, welcome back to the Education Building Division. We're about to start Team 3 as part of our final event here. Team 3 is joining us today in person, but they are from the University of Oregon. Just as a reminder, team, we'll have 8 minutes followed by 15 minutes of Q&A. Please look to us here locally. We'll hold up signs when we get to the 2-minute warning. With that, that's all my housekeeping. So I'm going to turn it over to you guys. And as soon as you start, we will start our timer. So welcome and good luck.
In an underserved community where poverty rates are high, education performance is declining, and access to fresh produce is a challenge, how can architecture have an impact?
How can a net zero elementary school serve the needs of both the students and the gateway community of Portland, Oregon beyond traditional education?
Hi, we are Team Palmarium, and I'm Kelly.
I'm Kenneth. I'm Connor. And I'm Evan.
And we are so excited to be here and could not have done so without the support of Professor Ihab El-Ziyadi and our colleagues at the University of Oregon. We engaged the David Douglas School District for a real project on a real site to serve a low-income community on the east side of Portland, Oregon. With a consistent decline in school performance, attendance, and mental health, our Gateway Elementary proposes a new approach for engaging students for hands-on STEAM learning within home-like classroom neighborhoods. By utilizing the Montessori teaching learning pedagogy to focus on holistic child development, we were challenged to think that a net zero school isn't just for the students, but a resource for the community by offering families after-hours care, professional counseling, food, green spaces, and showers. The 10 Solar Decathlon challenges served as an inspiration for our design to achieve a nexus between energy, agriculture, and biophilic design principles, resulting in a school building that acts as a third teacher for students and their community.
33% of our outdoor space is utilized for agriculture and outdoor learning. Fruit trees and berry bushes line the exterior walls to create a food forest to children to eat from as they navigate the orchard-like corridor. Sustainable features used in the building are on display in the form of an outdoor sustainability center that teaches students about growing food, composting, recycling, and harvesting energy. Solar energy and water harvesting are displayed in outdoor classrooms. Garden beds are maintained by students to produce food for the cafeteria and are free for students to take home to their family. Mason beehives are located along exterior walls as the species is not aggressive and they are great pollinators.
The central north-south circulation spine serves as an internal protected street, separating public programs to the west and private classrooms to the east. This naturally ventilated access creates a buffer around an orchard for learning. A green north-south corridor creates exterior unification, while green space at the south edge of the site is accessible to neighbors through a community garden and sports fields. Classrooms are designed to support the Montessori curriculum, learning through play. We employ sustainable design strategies such as daylighting, optimized shading, natural ventilation, water, and energy conservation, making our sustainable classroom a hands-on learning lab. Taking advantage of north and east facing walls, IESVE was used to simulate multiple window and skylight configurations to achieve ideal daylighting within classrooms. Considering the underperforming academics of the school district, we provided adaptable learning environments of different scales for a variety of learning needs. Classroom pairings have shared collaboration spaces, outdoor classrooms, and smaller breakout rooms for individualized learning.
The cafeteria has both connections to the gym and a STEAM laboratory on the second floor. The space can be open to the outdoors for natural ventilation, allowing for greater flexibility at lunch and after hours use. The gym and cafeteria come together to create a community center with an attached food pantry that serves extra meals and produce to those in need. In the gym, vertical thin shading, prismatic skylights, and cow wall translucent glazing provide adequate daylighting with minimal glare while reducing heating and cooling loads on the building envelope. The stage unifies the music room and the gym for assemblies, plays, and presentations with dynamic acoustical insulation that is controlled by the students.
The library is a double-sided space open to the north classroom. The space connects to a makerspace with built-in reading rooms and seating along exterior shaded windows. Through IESVE, we conducted glare simulations of March 21st at 9 a.m., 12, and 3 p.m. And results show that a daylight glare probability of 29%, which is lower than the 35% DGP imperceptible mentioned. Being connected to the classroom wing, the library is a hybrid zone with both the dedicated outdoor air system and radiant floors. The western public rooms rely on active systems, while the eastern classrooms utilize passive assist. The library and its adjacent rooms are hybrid, only using active systems as necessary. To bring daylight into the building, we implemented optimized side lighting, skylights, solar tubes, and light bulbs. Through a series of vents, windows, and night ventilation, we can flush hot air out of the building using passive cooling strategies. For ventilation and passive cooling, we incorporated ERVs in each classroom and solar chimneys in the common spaces. For heating, we incorporated thermal mass walls for thermal light. Radiant floors and chill beams are used to heat and cool the building. We ran a computational fluid dynamics simulation to determine the solar chimney size that would be effective for providing ventilation throughout the year. In this example, we have 2 pairs of stacked classrooms with activated airflow.
Most of our main building materials are manufactured within a 10-mile radius of the site, with all raw materials harvested in Oregon within a 250-mile radius. For our structural system, we utilize CLT and DLT mass timber construction. CLT can support our spans while providing aesthetic qualities when left exposed, thus reducing the environmental impacts of finished materials. In the ceiling, insulation between DLT boards provides acoustic insulation in rooms. Other structural elements are designed with recycled concrete from the pre-existing building on site. In continuing to push the boundaries of circular economy, we utilize a mycelium wall panel, which is made from low-value crop waste and bound together organically through a network of expanding mushroom spores, creating or transforming organic matter into a structural panel.
Using one-click LCA, we compare the use of common construction materials to our locally sourced ones. By using mass timber and recycled concrete on site, we are able to reduce our embodied CO2, earning us an A-grade cradle-to-grade rating and reducing our building cost to under $300 per square foot.
By conducting energy simulations at IESVE, we tested passive, active, and hybrid systems. Like thermal and daylight zoning, we were able to achieve maximum bioclimatic design efficiency to reduce our energy use to 10 kBTU per square foot per year. The average UI of a similar sized urban public school in climate zone 4C is 68, our target UI is 14. Our ultra low energy building has a net positive UI of -4 kBTU per square foot.
Keeping with our theme of food and sustainability, waste from the school, community, and an adjacent grocery store will be burned as biomass. The micro turbines are designed to turn this waste to heat water and send it to stratified storage tanks in our mechanical room. We estimate being able to produce 1.7 million kBtu of energy through this method for hot water heating and radiant floors.
We utilize the optimal orientation for PV panels on southern slope roofs to provide over 14 kBtus per square foot a year, exceeding our simulated building consumption of 4 kBtus. The roofs over the classroom wings can be rented out to third-party investors to generate income for the school district.
Taking advantage of the high precipitation levels in the Pacific Northwest, rainwater is harvested to irrigate our fruit walls, gardens, and to flush toilets. Additional water is stored in underground cisterns to be used during dry months. And with forest fires threatening our Pacific Northwest summers, we plan for how the school can function as a resilient emergency shelter in case of a natural disaster.
We have managed to design a net positive school for the less privileged members of our society suffering from poverty, food insecurity, and mental health issues. By finding potential in the constraints, our school children are energized daily by daylight in the classrooms,
Learn to protect the earth by growing produce in the garden,
nurtured by turning food waste into energy in our cafeteria.
Learning an energy conscious lifestyle through a hands-on learning environment.
Thank you.
Fantastic. Thank you to our team from the University of Oregon. We now have 15 minutes of available Q&A. And I didn't mention this earlier because we were doing so much technology stuff. But if you have other teammates that are either here physically or virtually for any team, those teammates are able to answer questions from the panelists, even if they're not a presenter. Only one who cannot will be a faculty sponsor. Didn't share that earlier. I had a lot going on, right? Okay. With that, 15 minutes of Q&A. Jurors, floor is yours now.
I guess I'll start. You mentioned smoke vents and being resilient to smoke vents. If there is a smoke vent that's not being used as the community evacuation center or something like that, are you able to still hold classes, like shut down your passive ventilation and have active ventilation in classrooms and still hold classes?
Well, our classrooms rely on our passive strategies. If I go back to we'll take into account how we designed it was thinking about safety and security, being able to close off wings. So this section of the school, these public areas can operate independently. And then also using our solar battery and our natural gas are able to kind of store energy. If we can see that, a fire is coming, we're able to store that energy to be used.
I have a follow-up question to that. I'm just curious if you considered the wider range of hazards and risks in your area other than fires, and how, if you kind of did research into that area.
Yeah, so I can talk about safety and security and kind of are looking into that. So there's kind of several things to think about, especially with schools. Thinking about, active shooters are kind of a big risk that we didn't think about years ago and kind of what we can do for that. So I'll kind of go back to that floor plan to show you. So looking at our main feature over here, we use our colors and to operating cars that are linked to potential hazards that are looking at natural stones. Looking at our feature has circulation, like how people enter the school. We have a visitor monitoring system, so you can't just go to the school through that other area. It's prevents intruders from moving out of the area. If you drop that into schoolwork, you don't actually enter the school. Around the school, in that aspect, you have to just like you're not going to see, and you shoot that closer and looking at all the vegetation already. Those are two strategies that answer your question.
Yeah, that's great. Thanks.
You guys had picked radiant floor heating and chill beam systems. Those can be a little less responsive and a time component to temperature fluctuations. Did you kind of look at that for the local climate and as students move throughout the building, like in a typical day? Just you guys had picked chill beams and radiant floor heating, which can be less responsive in temperature adjustments. They take a little while to modify. So did you?
We use that in conjunction with the building system, which first the chill beams are this for like the sensible heating or cooling, and we're creating that efficient building system for the leak.
I would also add to that and talk about kind of thermal mass walls. So thinking about the passing strategies and also the daylight that enters the classroom, where you can really utilize the daylight coming into the space, taking advantage of that eastern window access where you have that eastern sunlight in the morning that would warm up the classrooms.
Not a question, but a compliment. I did like the way that you didn't have an ideal orientation on your site. And so I liked the way that you created that. So you extended these wings and so you'd have more south. So that was great.
Can I add on to that?
Yeah, that's great.
Yeah, I'd love to add on to that and also talk about just our orientation on the site. I'll kind of go back to, I had briefly mentioned it at the beginning of our presentation. But looking at our location, and you can see there's a major highway to the left. So that was really that key driving factor of having the public spaces kind of as a sound buffer. And then thinking about how can we maximize the green space, but also tying into the question you had asked earlier about security, utilizing those classrooms in an orientation that would physically surround that space. So if you have children playing, you would rely on the vegetation for security, but also 3 sides are surrounded by the school.
That's great.
I have a question that I ask everybody. So is this a real project that will lead into construction, or is this kind of a theoretical?
Yeah, I'd love to answer that question. So as I had mentioned earlier, we're working with the David Douglas School District. So we had met with facilities managers for that district. The district, before we began the project, had put together a facilities assessment where they interviewed students, faculty, parents, members of the community to address a lot of the needs. So playing off of, why are the school rates declining? What can we do to make a difference? And that's when they came to us. So the school is currently in the process of securing a bond. So being a studio project, we were able to put together all of our ideas and present this to the school district, and they're able to use our work to help aid in that process of getting a bond to hopefully build our school, or at least utilize the work that we have done to inspire their design moving forward.
One I like chilled beams and radiant heat are great, comfortable system. You have combined heat and power using digester gas with stored hot water. And this is probably a common comment is you had on means is probably not a great way to estimate. They had 33 cents per square foot for plumbing and $9.42 per square foot. If you did get into a planning stage, you might want to take a look at the systems. I mean, probably off by maybe a factor of 10. But you don't want to go down too far down the road and then find out that the budget is a problem. And I think that as far as this HVAC system selection, isn't your climate is 4C, isn't it pretty mild? I mean, you don't have extremes, do you?
It is relatively mild, yes. But there are, you can see it in the beginning of our presentation, we had a graphic on heating degree days and cooling degree days. Where most of our heating degree days are kind of in the summer break, but yeah, climate is relatively mild, not very many extreme weather days.
I will add on to that, just with different environmental factors. There is more extreme weather happening in that climate, where we in Oregon this past week, faced snow and hail, which doesn't normally occur this time of year in years past. So I would say, it is relatively mild, but you have to account for extremes like that.
So, okay.
I thought the use of the one-click program for the embodied environmental impact analysis was great. Was that a kind of iterative process that was done during decision making, or was it more of a here's our design, now let's kind of see how that pans out on the embodied impact?
I would say that we had discussions along the way of kind of the material choices. kind of looking into that use of mass timber, I mean, looking at our numbers, I thought it was a significant factor in our budget. So I think that was a conversation we had all along, looking at traditional schools, especially seeing how much steel and CMU is used. That's something that we talked about. You know, do we really want to have those materials? Looking into the cost of it, we determined that it was better to have a lower impact. Also tying back to our locally sourced materials and thinking that, you know, this greater upfront cost at the beginning would have a better long-term impact and also be utilizing the resources of the state of Oregon.
Thanks. Did you work with someone to actually get real quotes on the CLP or discuss like the local manufacturers, what it would cost or anything like that? No, we didn't know, but we did a lot of just research online and looking at different products manufactured to find some of those prices, but not so much working with sold to discuss the prices on those.
I will say that more on the research side, we did talk with professionals in the field who have used this material before, and they told us about how they have used it in school projects, how effective it's been. You know, professors that have talked about kind of the spans that you would use for it and how this is a practical material to use.
I have a couple daylight questions for me. Yeah, so so I was just curious with the gym, if I was reading it correctly, and maybe I missed it, it is west facing. So I was just curious how you're going to deal with glare in that, or maybe it's not. Maybe I was misreading it. Yeah. Okay, so it's not. I thought in the plans that there was a.
These windows face west.
Okay, just those, but not. There's okay. Okay.
We have like vertical shading devices and kind of diffuse like through skylights as well. So.
Yeah.
You can kind of see the vertical shading on our rendering.
Mhm. Yeah.
And then
Great. Yeah, that's great. Yeah, I like the DGP metric, so it's great. Seems like a thorough analysis, and yeah.
We did simulate the windows.
Yeah.
So and other spaces.
Yeah, maybe one comment to add is make sure to add in like a little key so we know like where those renderings, because those renderings can be really, really powerful, but it, like you said, it's important to know which direction, but yeah, it's great.
We try to orient our graphics and the direction we're going to.
Yeah.
Understand the content.
Yeah, that's great. Yeah, no, I like that. For me, I always feel for daylight, there's having multiple metrics is important. So I see that you did that. So having the DGP, which is a point in time, but then having the grid base, which is a grid based annual metric. So yeah, that's great. I will say I did notice the SDA is quite high. So technical question, you might not know the answer to this. I don't personally use IES, but there is a shade algorithm that happens with SDA versus just regular daylight autonomy. I'm just curious if you know whether that shading algorithm is taken into account, because the 90% SDA seems very, very high to me.
Algorithm.
Basically the metric as prescribed, if you're above on the ASE, the blinds must come down in the simulation. And so it lowers the SDA. So I was just curious because 90% is just much higher than I would think. Yeah. So maybe just something to look into.
Jurors, we have about 3 minutes still, so maybe 1 or 2 questions, depending on how short they are, we have time for.
Did you guys take into account some operations and maintenance stay with your biomass generators or entire school building?
Yeah, we positioned our biomass generators towards the south end of the site with a second accessible loading dock. So maintenance would be quite accessible. If it was needed, yeah.
I can also go back to our overall plan that might show context a little bit better. So seeing kind of the orientation of the site
So I really love the concept of the indoor outdoor spaces and the planting, and the overall concept is great. I'm just curious with your water piece, did you do analysis on the cistern size? And did you think about how that would be collected on a daily basis and do analysis there?
Yeah, so our cistern size, we sized it to about a quarter of our overall rainwater catchment. And here's our graphic. So we're collecting around 1.5 million gallons a year, making our cistern size approximately 375 million gallons. This can be used for irrigation of our gardens, as well as gray water coming from our sinks and dishwashers, used for about 20% of our.
Great. I like the graphic. Nice.
Does local code permit the gray water reuse?
Yes.
Any last questions, jurors, or are we are good? Rick, do you have any last question? If not, we can wrap up for University of Oregon.
No, I'm good. Thanks.
Well, thank you again, students.
Thanks, guys.
Great work. Up next, thank you. Of course. Up next, we have our team from Carleton University. They are virtual, so hopefully you can hear me and you're online right now. Begin turning your cameras and mics on. I'm going to come around, get your slides pulled up. All that fun stuff.
Yeah. Which one was this? Maybe you can find it.
Yeah.
No. Well, I'm 5 feet on the camera. If the camera's to the presenters that are live here. Just further complicate things. Yeah. Just check. Oh, that's longer. Okay.
Yeah.
All right.
Thank you.
I'm going to simultaneously do some stuff, Carrie. So just keep asking questions.
No, you're good.
Okay. Amber, I see you. Can you hear me? And can you come off mute so we can just confirm audio is working?
Is it working?
Yes, we can hear you. Can you hear us okay?
Yeah.
Presenter cam is, wait, presenter camera as in this, if you're standing here, is this machine.
And then like.
Juror camera is her machine.
Yeah. Yeah, same. I'm like,
That one, face her forward.
so they took the building.
That's this one.
Well, no, but some of those sections are just like. Okay.
Physically complicated or whatever.
Amber, are all your teammates here? I'm multitasking, so I apologize.
Yeah, I think our presenters are here for sure. It'll be Julia and Osama. They have their cameras on.
Yep, I see Osama. You said Julia?
Yeah.
Oh, great. We're trying to get your guys' cameras spotlighted on the Zoom screen as well. I think I just, yep. Hopefully you can see your slides, correct?
Yeah. Dina will be doing our slides for us.
Okay, can you request control?
Yeah.
Once you do that in the Zoom, oh, I see it. Excellent. Okay. You should get control here, and once you can
I'm just
test.
gonna, yes, I'm gonna test it out real quick. Is that okay?
Go for it. Yeah, please do. You may have to first click your mouse inside of Zoom. There it goes. Okay.
It's just
That's
live.
cute. Yeah, there's going to be a lag. Sorry, there will be a lag. We're going through lots of internet cables and some wireless. So, okay, that's working. Are you guys are all here? That's fantastic. We're gonna pause just for a second, just to see if there's, we're just sorting out a couple AV things on our end. So just hang tight for a minute or two. This one, because the forward camera is the problem. Okay, your sound though is coming. This is through that. That one's through that. Because this whole board is through wireless.
Okay,
So sound is
that's
coming
why.
wireless.
That's why you're confused.
Now, I can take, I'm hosting the meeting.
Yeah,
So I don't want to come off our mics.
Okay, let me see.
Okay. Carrie, is it okay if I begin? Thank you, Carrie. All right, team, just a second. I'm going to come around. Don't worry. I think we're doing great. We only have 2 of the 3 computers hardlined in, so we're having a little bit of lag in audio versus video, but we're sorting it out. Teams are doing great.
Okay.
They are hanging in there with us. So we're doing fine. We're still a few minutes behind, but we have 1 buffer slot later in the afternoon, so we're going to be fine. Thanks, Amanda. And Carrie's running around here, and I'll make sure he needs anything. Thank you. Okay, I am back around to my desk. Can you guys hear me okay?
Yeah.
Fantastic. And we got all 3 of you. We've checked all 3 mics. Can you give me one more confirmation to try and move the slides? Okay, so that's all working fantastic. Okay, well, let's go ahead and get started. So for those in the room as well as those online, we are about to kick off our 4th team of the day. This team comes to us from Carleton University in Ottawa, Ontario, for those that aren't geography whizzes, because I'm not, so I had to look at my sheet. So welcome first and foremost. As a reminder to our student presenters, you'll have 8 minutes that we will start that clock as soon as I hand over the floor to you. We will give you a 2-minute warning via one of the cameras that is pinned to the Zoom screen, so you'll see a background change if you haven't already seen it throughout the day today. Once we get through the 8-minute presentation, we will then open it up for 15 minutes of available question and answer from our 4 jurors, and that'll be that. So we are set on our end. I'm going to hand the floor over to our team from Carleton University, and we will start your clock as soon as you guys are ready. So take it away.
Good afternoon. It's an honor to be presenting our project titled Start Smart Elementary School. All efforts put towards this project are contributed by Lat 45, a team of 12 undergraduate students in the Civil Environmental Engineering Department, along with the support provided by Dr. Liam O'Brien and Dr. Brock Gunay. The 9 contests are shown here, and their icons will be seen throughout the presentation for further context. Our site is located in Climate Zone 6, and the codes and standards which guided our design are listed here. A source EUI maximum target of 200 kilowatt hours per meter squared is set. Our school's lot is situated in a suburban neighborhood called Barhaven, located in Ottawa, Ontario, Canada. I would also like to acknowledge that this land is the traditional unceded territory of the Algonquin and Anishinaabe people. Our current target market includes young middle-class families, students, staff, and faculty. And finally, our site is currently being developed by Ottawa Carleton District School Board, so our design serves as a more environmentally conscious alternative. Our design goals include creating a child-oriented design that is accessible, making it self-sustaining while considering occupant mental health, maintaining a low-carbon footprint, and creating a functional and flexible learning environment for students.
Our design tries to optimize visual connection to the outdoors, maintain the flow of the building, and keep older students and younger students separate. The gymnasium is centralized for thermal massing, acoustics, and helps visitors in the main entrance area away from classrooms. The library, lobby, and staff rooms are facing east intentionally because these rooms have decreased occupancy, so direct sunlight is wanted for occupant health and to increase potential heat gain. To reduce glare, stacked windows and interior shading were used. The top row of the windows are hopper style, and for the south facade, light shelves were used to create deeper daylight penetration, and overhangs were placed to reduce solar heat gains. The interior was designed to be modern and functional, but fun and dynamic. The classrooms are colorful but not distracting, have adequate storage for both students and teachers, interactive surfaces, and quiet areas for students to relax and refocus. Built-in planter boxes in the window help with student performance and mental health and give faculty the opportunity to promote responsibility, provide hands-on experiences, and connect to the outdoors. To reduce glare, all the workplace surfaces are wood, and the walls and floors have a matte finish to diffuse light. The ceiling are a light color to help transmit indirect light throughout the space. To help with interclassroom noise, each room's locker space is along the joint wall so that the added mass will reduce disruptions and are not located directly next to the gym. Acoustic tiles are used on the ceiling, and in larger areas like the lobby, library, and gym, extra sound dampening treatments are installed to help reduce unwanted noise. All the interior walls were able to achieve an STC 60 rating. CLT, wood fiber insulation, and reclaimed wood were used for their special acoustic qualities and better life cycles. Our exterior wall assembly is a 3-ply cross-laminated timbered structural system with rock wool rigid insulation, recycled wood fiber insulation, and reclaimed wood for interior siding. Exterior cladding is a combination of local limestone from the main facade and vinyl-backed insulating board for the others. Both floors and the green roof are made of hollow core concrete, and the floors use Sono floor acoustic insulation and vinyl composite tile finish, and the roof and ceiling are paired with XPS insulation. The overall window profile consists of 3 clear low-E coating panes filled with argon gas and framed with vinyl. The window performance analysis determined that the thermal transmittance value of the assembly ranged from 1.1 to 1.3 watts per meter squared Kelvin.
We have chosen an extensive green roof system that features species accessible in Ontario. This assembly shown creates a robust growth foundation for root attachment that increases insulation between roof layers. It was determined that a substrate mix of clay brick, pumice, and perlite would suffice. Using inorganic substrate is beneficial as it improves soil structure in cold, dry climates and is drought resistant. There will be 4 air handling units serving the 4 main sections of the school. This will be divided into the north and south wings, the core area, and finally the east facade. Supply and return air will be fed through a hollow core slab system. Benefits of the slab include acting as a battery to shift peak loads when the building is unoccupied by storing heat produced by lighting, occupants, and solar gains throughout the day. These loads are rejected through night flushing during the summer or stored for the next day during the winter months. Noise is reduced as fans can be located in the corridor's drop-down ceiling with typical ducting systems. Our site will use a closed vertical ground coupled heat pump system. Our considerations while developing this were the soil composition, depth to bedrock, to density material, to water table, and our average moisture content. Together, this would constitute an extraction rate of roughly 40 watts per meter squared. Altogether, this will consist of 196 boreholes covering about 22% of the total available area. This configuration is able to supply 100% of peak energy consumption using a depth of 115 meters per borehole. In order to meet domestic hot water needs, StarSmart will incorporate solar thermal panels to be mounted atop the fixed shading on the south facade. A total of 70 evacuated tube panels will be able to meet all hot water requirements of just over 900 liters per day, while leaving all roof space available for PV panels and water collection. It is determined that a total of 665 PV panels could be mounted on the roof when considering spacing to ensure no shading occurs on the panels. The optimal angle and azimuth were determined in order to calculate the total electricity generation. With the current setup, a minimum of 80% of the school's electricity demands will be met, and the remaining will be offset by the Ottawa Hydro power grid. The addition of a water collection system will be used for non-potable water resources such as outdoor irrigations, toilets, and urinal flushing. Rainwater will collect in the roof drainage system and flow to the green wall. The final drain pipe will connect to 3 50,000-liter precast concrete cistern storage tanks located underground below the local frost penetration depth of 1.2 meters. The tanks will include several screens on both the inlet and overflow outlets to prevent insects from contaminating the water. In addition, each tank will need to include a manhole access point for easy maintenance, an electrical water level sensor, and a pressurized pump outlet. The chosen water treatment system will exclusively be used for rain and gray water. The system will consist of a coarse filter with a surge tank, followed by a fine sand filter and UV disinfection.
The embodied environmental impact analysis was conducted using the Revit plugin Tally. The school's exterior walls with the limestone veneer is the main contributor to the global warming and smog formation, while the materials making up the interior load-bearing walls contribute most to the acidification and eutrophication. Thermal and moisture protection and finishes cause the highest impact to global warming potential. Talc accounts for carbon sequestering, and therefore the wood products result in a negative contribution of 12% in the overall global warming potential. Shown here is a southeast view of the energy model created. Iterations to reduce loads through passive measures, then mechanical, were completed. The initial iteration used our window designs with mass walls for the materials, included a CAV system with no heat recovery. And iterations were taken to include VAV system with reheat, economizer, demand control ventilation, and lighting control to meet our solar decathlon requirements with an EOI of 140 kilowatt hours per meter squared. The cost of our school is broken down on screen, leading a grand total of 23 million or 275 per square foot in Canadian dollars. The payback periods for photovoltaic, solar thermals, and geothermal systems were determined to be 10, 4, and 7 years respectively. This concludes our presentation, and we thank you for listening and invite you to ask any questions.
Thank you, students. Wonderful presentation. Okay, we now open up the floor to our 4 jurors. We have 15 minutes available to us for Q&A. Students, feel free to back through your slides as needed on your end. But with that, jurors, the floor is yours.
Yeah, I have a couple of questions. One comment is on your summary, you had the site EUI at 144 kBDs per square foot per year, and the requirement was 63, but I went back into report and you did change your units several times, but anyway, it kind of threw me off at first.
Oh, sorry. So yeah, 63, but that's in imperial and ours is in metric.
But it's a just comment. But as far as your green roof, did you have a green roof throughout the roof area? And are you putting the PV panels on top of the green roof? And how much water do you really get to reclaim when you do have a green roof? And how much rain do you get up in, what is it? I forgot what your location is in Ottawa. So I just haven't dealt with the green roofs that much. So I was just curious. So.
I can jump in and talk about that one. So pairing the PVs with a green roof is actually helps the PVs to increase their lifetime and become more efficient. It helps to regulate their temperature. So pairing the green roof with the PVs doesn't really impact the water collection that much. We just put the drainage in spaces where plants wouldn't be able to grow as well. And the amount of water we collect is just based on like the square footage of the roof of the school. And in Canada, it rains, I would say like 8 to 9 months out of the year. And then in the winter when it snows, we'll still be able to collect that water once it starts to melt and thaw.
Okay, thank you.
Great presentation, very thorough, and follow-up question to Rick's about the PV on the green roof. It sounds like you thought it out really well, but just quick follow-up. Did you think about like maintenance and also like the plant growth aspect? Is that a consideration or concern?
I can take that one again. Yeah, so we did have a slide previously, or we detailed it in our report as well about the different types of plants. So we specifically researched plants that thrive in Ontario. So those are like low-lying perennials, sedges, mosses, sedums, plants like that don't need a lot of maintenance. We do have maintenance access for the roof, and part of our design included non-vegetated areas as well for maintenance access. So the whole perimeter of the roof has a walkway around it that's non-vegetated, and yeah, so that's yeah.
Yeah, I guess I was more curious about the maintenance of the PV. I should have been more clear. Like, because usually you need like walkways for them to. So just curious how difficult it would be with the plants there to do that maintenance.
Yeah, so because they're like mostly low-lying plants, they're not really going to interfere. We're ensured that the PVs would be placed high enough that the plants would never grow to shade them at all. And some of the plants they thrive in shade as well. So they'll work well together. And yeah, I'd also say that part of our design included looking at bylaws in Toronto, where they're actually mandating green roofs be incorporated into all new builds.
That's great. I haven't seen them integrated like that, so it's good to see.
Hey, Shannon here, just one quick comment and then a question for you. I think you guys covered the embodied environmental impact nicely in your slides here today. I think I kind of missed it when reading through the report initially as it was down in the appendix. So maybe just a quick reference of where to find some more of the detail, within the body report would have been helpful. And then I just had a question. I thought your guys' indoor environmental quality analysis was also really well-rounded. Did you consider any LEED or collaborative for high performance schools or well building standard certifications to kind of pair with that indoor environmental quality component?
Yeah, I can jump in a little bit on the acoustics for that one. All of the walls and the floor and ceiling were made to meet the WELL pilot addenda for education buildings. So they all have the required STC rating for noise. And they also have like the thermal ratings that go along with that because they kind of match up.
Yeah, no, that's great. Thank you.
Just a comment about the floor plan. I noticed there wasn't a cafeteria kitchen. Is that a design choice or is that something different from Canadian and US schools?
I can jump in on that again. So in Canada, most elementary schools don't have cafeterias and kids eat in their classrooms. So that was something that we looked into extensively and actually looked into there is a school on the site that we're working on and they're actually making one. So we kind of looked at their room requirements as well. So they also did not include a cafeteria or a kitchen. So
I'll also just add on to that and say that there is a kitchen for staff on the second floor. So if for any reason like there was a need for the kitchen for, say pizza day for the students, there is still a space allocated that could be used.
I've learned something now.
Yeah. You guys kind of mentioned demand control ventilation. What areas will that be utilized?
Sorry, you said natural ventilation?
Sorry, the demand control ventilation.
Oh, demand control ventilation. Yeah, I only implemented it into areas where the occupancy would be varying throughout the day. So you can go back to the layout actually. So primarily, mostly in the gym, library, office areas. I didn't implement it into the classrooms because they have a pretty set occupancy for most of the day. It's pretty set, whereas like the gym and library would vary very much throughout the day.
Yeah, I think the maintenance guys would thank you for that. So that's proper, yeah. And then overall, I think the just general design of the building is very simplistic, which I think lends to keeping costs down and also that thermal balance, which is nice. Did you guys play with any other sort of architectural features just to get a little more of that curb appeal or kind of inspiration, for the community as far as just the visual approach?
We tried to incorporate some more like architectural features more so inside the building with like the green wall, stuff like that, even if we did have more of a box shape that you could have some more interesting features. We played with a couple of shapes for our layout, whether it was like an H or like a curved wall on the side, but we just found that this one suited all of our needs a lot better.
Okay, thanks.
One thing I appreciated in the presentation here was kind of the detail on where the solar thermal panels were. Those a little unclear in the report, but I appreciate that it's for shading on the windows.
Yeah, I'll just jump in there as well to talk about those. Part of the benefits of using solar thermal panels is that they're functional between an angle of 0 to 70 degrees. So that lends them really well to being able to mount on the south facade of the school and still produce all of the domestic hot water needed.
Related to shading, I have a few questions about daylight. I can see that, you've thought about it. I was curious about the 18 inches of the depth of the fins. And I was curious if you analyzed that and evaluated that to make sure that that was sufficient for your needs for glare.
Yeah, so we just sort of tested out the typical like 1 foot, 1.5, and then 2 feet, and then combining that with either we wanted to have like fixed shading on the top or on the bottom or a combination of both. So we found that the combination of both best suited our needs, and then we went from there.
Yeah, I think we did close to 20 iterations with different window shapes and different like shading and systems. So this was the one that we chose because it was best for getting the most daylight into the classroom without the most glare.
That's great. Yeah, that's really nice to hear that you went through that iterative process. I feel like that's a really good way to arrive at an optimal solution. So fantastic to hear that you did that. Sounds like a lot of thought went into that. I guess the other daylight comment I had was you noted that there was triple pane glass, and I'm looking here. I can't quite see, but in your report, you'd mentioned that would provide better daylighting, and I would just, caution that the VLT, that the visible light transmittance, would be lower. Not necessarily a bad thing, but I don't know that I would immediately say it provides better daylighting, but it does sound like you've done the analysis to back that up. That's right?
I think so, yeah. Like I said, we did, I think, close to 20 iterations, and that was the one with the triple glaze that ended up having the least amount of glare.
In combination. Okay,
yeah,
great.
For your guys' ground source system, I didn't notice, were you doing vertical bores, and did you have a section of the property where that was going to be sited? Yes. Okay.
Yeah, so it is vertical. We have the option of doing horizontal, but we found just like with our cold climate that with also the amount of boreholes that we're going to be putting on this site, it doesn't make sense to have them horizontal. It would take up a lot of the space, and there's just more concern with freezing and stuff like that.
Yeah, makes sense. Awesome, thank you.
I have a question about the wall system and the analysis that you did for that. You noted that you did therm analysis. And I was just curious if the only analysis that you had done was the section that you'd shown here, where it's sort of 1D cut through. So I guess sort of a question and comment. If you do a 2D analysis, that derates the assembly, so you're not at as high of a value as you might think. So I was just wondering if you took that into account.
No, it was, sorry.
Yeah.
It was just a 1D analysis.
Yeah.
For that, yeah.
Be careful, it can make a big impact, and there are some simple quick ways to do that calculation as well. There's like some tables you can use in addition to therm. It's great that you did do the therm, and it's good to see that, but it can make quite a big impact. So, but I did see that you had quite a clear understanding of building science fundamentals and the different control layers, so that was great to see.
We do still have about 2.5 minutes or so of Q&A left. So maybe a short 1 or 2 questions from our jurors if they have them.
I'll ask my standard question. So is this a real job, or that could be built, or is this strictly theoretical?
I can answer that one. Our site is being currently constructed on. I believe they already have plans to put a school on the site. So it will not be built on this site because they already have the plans and the budget to go ahead with that. This was more of a alternative to what they were proposing.
So did you know why they well, anyway, was this building kind of planned or designed prior to them building, or was the other one under pretty much under construction when you started?
Well, go ahead. Oh, okay. So the school is in a newer neighborhood that is being developed right now. So they are expanding it to complement the other school in the area to allow for the population growth. And they started it before COVID kind of hit and the designs were started, but because we've had a lot of shortages in supply and labor over the last couple of years, it's been delayed a little bit. So they are starting construction really soon, but not yet.
Okay, well, thank you.
I will also add on, as far as like feasibility of the project, the cost of everything was more determined on like a materials basis and didn't include like the cost of a consultant or a contractor or labor or even contingencies as well.
And do you know if the project or the school that they ended up with, was it designed with energy in mind, or was it pretty much just a plain old design? So.
Pretty sure it's plain old design. I'm not quite positive, but I think it's more budget than design.
It seems like it's always budget. So.
You kind of just alluded to this, but the $275 per square foot, is that kind of low, medium, high for your area? It's definitely low for our area.
So it's in Canadian dollars, and I would say that it is within the typical range. I did do an analysis based on existing builds in Canada, the US, and Europe, and I accounted for inflation, exchange rate, and I found like the average cost for a school to be between 20 and 25 million. So 23 million fell like right in that normal range. But if it seems a little bit low, it's probably because the cost of labor is not included.
Right, makes sense. Awesome, thank you.
Fantastic. Well, that wraps up our 15-minute Q&A. Thank you, students. Thank you for joining us and presenting from Carleton University. A round of applause. Okay, up next, our final team before we have a lunch break from Virginia Polytech. They are in person here, and we're going to do a couple technology swaps to try to alleviate some audio things that are happening on Zoom. Everyone bear with us. Stay tuned, and you'll hear me coming back on here, letting you all know when we're ready to go. You guys do that. If you want to try it. Well, we'll leave this one sitting here, and if it starts taking longer, we'll finish it at lunch. All right, come on. Just bear with us. We're gonna. I think some of the audio on Zoom is. You've just swapped over. I'm gonna attempt to mute the main mic. Yep. Okay, welcome back. Can Rick, perhaps if you're nearby your unmute button, can you confirm you can hear us okay over the microphone system here?
Yes, I can hear you.
Fantastic. How is the clicker working for you guys? All right. That's fine. Let's just give this a quick check. I think it's just out of the. Yeah, just go back to the PowerPoint. You guys, you think it's, you know, it's all me. I had the Zoom screen paused. So that nobody had to see all of our transitions. Alt tab over to. There we go. Okay, thank you, everyone. Okay, let me come back over here. Okay, we're about to kick off. This is team number 5 for the day. So welcome back, everyone that's here in the room and those that are joining us on Zoom. Here we have a team from Virginia Polytech. So just as a friendly reminder, 8-minute presentation. We won't start the clock until, of course, we hand it over and you guys begin. We'll give you a visual prompt here with our flashcards. And I will give a quick visual prompt to those listening in on the camera, but then I'll remove it so they can still see you guys. And then we all have 15 minutes of Q&A. And just for everyone's good news, after that, those that are here, we have a break and it's lunch here. So I know we're all anxious to stand up and walk around. With that, I think we're ready on our end. So I will turn it over to you guys as soon as you're ready. The floor is yours.
All right, hello, we're Team Carleton. I'm Ari.
Howdy, I'm Trevor.
I'm Sarah. And I'm Kat. And welcome to Point Present, a high school for the future. We are transforming a former brownfield site into a career and technical education school and data center that will educate the next generation of innovators. Our site is located in Alexandria, Virginia, just south of Washington, D.C. 40 miles west of the site is the largest concentration of data centers in the United States. These buildings consume land and electricity in complete isolation. We propose to bring the data center into the city and integrate it into a distributed network of heat and energy reuse. Our proposed location is a brownfield site, once a major rail yard that transported freight and passenger lines through the mid-Atlantic. Most of the tracks were demolished in the 1990s, and the site became Potomac Yard, a sprawling strip mall and surface parking lot. In 2017, the city of Alexandria approved the North Potomac Small Area Plan, a master plan that envisioned a sustainable mixed-use neighborhood all within walking distance of a new metro station. The building 7W in yellow will be the Virginia Tech Innovation Campus, and our buildings will be buildings A and B on the map. The Innovation Campus focuses on education of computer science and engineering in partnership with the Amazon headquarters just north of our site in Arlington. Point Present will extend the career pipeline into our school and curriculum. Our extensive site includes an orchard of solar flowers, a stormwater infiltration basin, a permeable plaza, and PV pavers. Beyond the building, we want to take advantage of green space and make our solar energy generation visible to the entire world. Our site is located in climate zone 4A with hot, humid summers and cold winters, sometimes all in a single day. The 2 existing Alexandria high schools will fall short of projected enrollment within the next 10 years. Point Present's 500 student capacity solves this problem with a budget of $360 per square foot. We provide a curriculum that gives students hands-on learning opportunities to be involved in sustainable design, learning both in the building and from the building. With all this in mind, we have 2 design objectives. We want to normalize high-performance building, utilize the building as a teaching tool, distribute heat and energy, implement a microgrid, and maximize passive design strategies.
So the site was originally master planned as two separate buildings, parcel A and parcel B. We then created an elevated bridge connecting the two parcels that provides clear visual and pedestrian access to the Potomac River and the trails beyond. This placed collaboration zones between the two programmatic elements to foster student engagement. We located the data center towards parcel B, and because they require minimal glazing, we're able to maximize solar generation on our entire south facade. Our building is primarily oriented north to south, and the site will receive significant shade because of the proposed building to the west. And based on the allowable heights from the master plan, we assumed the worst case scenario for shading. Using Grasshopper for energy modeling, we mapped the shade of our surrounding buildings to determine the optimal placement for the horizontal fins on the south facade. By angling the PV fence, we turned our east wall into several dozen south-facing walls to better capture solar energy. This also blocks glare from directly entering into the classroom spaces, which greatly reduces glare. We also elevated our PV roof array to combat our shading conditions. The high school uses the hybrid structural system of mass timber and low carbon concrete. And because the servers are running 24/7, we have no opportunity for night purging. Instead, we have insulated the building to capture and direct excess heat into our heat exchange system. Within the school, our mass timber structure significantly lowers the building's embodied carbon and provides opportunities for biophilia where the structure is exposed. The exterior materials include insulated metal panel, charwood siding, PV glass panel, PV louvers, and an interactive display screen that acts as the building's marquee. And in this section, you can see on the ground floor that there are common spaces that can be used by the school or rented out for community events. We've also provided generous corridors that have been designed for flexible activity-based work environments. And so getting a closer look at some of our typical classroom spaces, we've integrated a number of mechanical and passive systems to improve air and thermal qualities. Labs and classroom spaces are configured, closed and planned to allow for easy maneuvering between hands-on or lecture-style learning environments. And students can step outside on our exterior balcony and get up close and personal with one of our vital building systems, the vertical PV fence.
Moving to the first floor, the double height cafeteria acts as an anchor between the education and data center program. We provide a direct view into the server space and relay real-time energy performance onto interactive digital displays. The connecting bridge is home to the media center and collaborative study spaces. Vertical fins on our eastern facade shade the building while providing views to the park and river beyond. We chose to expose color-coded conduits as a teaching tool for the building. At the entrance of Building A, a social stair engages the school with public lecture and community event space. Fabrication labs on the first floor can be opened through a series of overhead doors that connect the campus with outdoor space. Circadian lighting in labs and classroom spaces promotes student focus and productivity. We reduce our lighting load by using daylight and motion sensors based on occupant demand. We propose a microgrid of net zero buildings. With the belief that there is no such thing as waste heat, we harness the data center's heat production and distribute it through load shifting. In summer, we provide district-wide hot water. In winter, we heat our plaza for snow melt and meet our building's heating demands. The data center heat is collected through a central coolant loop that systems draw from based on demand. This loop services ventilation, radiant flooring, domestic hot water, and district hot water. It then runs through a geothermal system and back up to the data center. We've also provided stormwater management for gray water and irrigation. Using these systems, we've greatly reduced our heating demand and greatly increased system efficiencies. A typical high school EUI is about 104. With our strategies, we have achieved an EUI of -33 with renewables, creating a net positive 40. So this is the new model for distributed data centers. Our 5 megawatt data center provides 1.5 megawatts of server space for research, training, and educational support spaces. We use immersive cooling tanks to submerge servers so that we can pack more data into less space. 100% hydrogen backup generators are no emissions and zero toxins.
So this is Point Present, a net positive high school and data center. Though we are presenting this to you today, we have designed it for the near future, when our innovative technologies are industry standard, when there is no such thing as waste heat, when every BTU and creative teenage mind is a resource full of energy. Thank you.
Thank you.
Wonderful. Thank you, guys. Okay, we're going to open it up to our 15 minutes of Q&A. Now, I know our team for Virginia may have some students, team members that have joined us virtually. So I just want to remind you that you are allowed as a team member to answer Q&A. Keep in mind you're muted right now. So if there is a particular question that a team member from Virginia who's online would like to answer, or if one of your teammates here prompts you, just make sure you unmute yourself. With that, we'll have 15 minutes of Q&A. So jurors, take it away.
Yeah, great presentation and concept. Very innovative. You can tell just by the first glance at it. So great work on that. My read through your design narrative, I noticed that there wasn't a lot or maybe really any on daylighting. Then you did cover that in the presentation. So that was one of the pieces I was definitely looking for. And so not really a question, just a comment. A great job with the innovations. And one of the things that is really important is to understand the case without the shading. So you did do that and did the non-shading case and added the shading. So yeah, great job.
I have a few questions. So this data center, it's part of the school, is that correct?
Yes.
It's not a co-locate or anything like that. So is the school on board with immersion cooling?
I'm sorry, could you repeat the question?
Yeah, is the school or their data center people, are they on board with the immersion cooling concept?
Batul online, would you provide an answer for that question?
Yes, they have. So our engineering strategy relies on integrated systems, innovative technologies, and an attitude to resourcefulness. So yes, we have chosen immersion cooling system tanks, and definitely they're on board. Yes.
Yeah, every time I proposed it, I had a lot of pushback from the operators of the data center. But my question too is, so with the immersion cooling, that enables you to provide fairly high temperature waste heat. What temperature would that be?
I can answer that question. That temperature is 104. This is the output of the tanks, and the returning coolant, the heat is 89 Fahrenheit.
Did you say 104 degrees?
104 degrees, yes.
So you had that piped over to, I don't know if that was the retail center, but typically if those are existing buildings, 104 degrees wouldn't be sufficient for most systems to heat unless it was like a heat pump, or, I mean, are those existing buildings?
Can you repeat the question? Are you talking about one of the earlier slides?
Yeah, you had like a microgrid or whatever. You were piping the waste heat to neighboring buildings.
Yeah, the district hot water, our concept is not to fully provide it, it's to exhaust all the waste heat. Because in normal data centers, you just exhaust it to the air. So even if we can get that 104 down to 89, that's a lot more energy efficient than just pumping it out. So we're just kind of helping the district instead of fully providing for it.
So are those existing buildings, or would those be new buildings?
They're all proposed zero energy ready.
They're not yet built though.
Yeah, mixed
Okay.
use.
Okay, question is, if as far as your overall EUI, can you, I'm sorry, one of the drawbacks of, so anyway, my question is, so can you, if the data center is part of the school, it consumes 39 million kWh per year, and your total PV is 3 million. Can you say that that's all? Don't you have to take into account that that's part of your parasitic load on your building, or can you just totally ignore it? I'm just curious. I asked this question to some people and then nobody could answer it. So
So our UI numbers are for our school only. We recognize that a data center is best measured by PV, our use effectiveness. And so our concept is to use all of our solar arrays to power our school and any excess heat is fed back to the public grid, because a data center will only take public grid will only never get back, and maybe in the near future there might be technology to allow for a net zero data center. But our UI is only for our school, and our data center is on a separate feed from the public grid, and we're a renewable input into that public grid. We're hoping as the grid it's more renewable, has more renewable energy inputs, it'll be better fuel. But all of our excess electricity that's might need in school is fed into the public grid.
That's what I was asking originally, is the data center part of the school? So I didn't know how to treat that 39 million kWh. But one other question, you had excess waste heat rejected to the river. Typically from environmental standpoints, they really don't like that. Did you research that at all?
Yeah, so the digit polyphon on the left of the image is a series of a tiered water features that allow the water to immediately back to the existing outdoor temperature. We're actually feeding groundwater from our water table that's 30 feet below us, and then any overflow is fed into our 4-mile run, which is north of our site. And it's sized to retain a 2-inch storm, detain a 4-inch storm, and any overflow is fed to it. And so it's a overflow mechanism of our stormwater as a site as a whole. But the center polyphon is what takes our heated water and ensures it's going back into the infiltration base, infiltrated back into the ground plane at the right temperature.
Okay, thank you.
I was curious about your embodied carbon piece of things. You kind of touched on it, but I was just curious, like your process with the life cycle analysis, like, what program did you use? Like, what were your findings from that?
Okay, Sarah E. online, would you provide an answer for embodied carbon? Sarah there?
I'm sorry, can you repeat the question?
Yeah, sure. So I think you touched on embodied carbon, but I don't believe it was super extensive in the design narrative. And I was just curious, like what your process was, what, how you thought about it, what takeaways you took from it. Did that inform anything that you landed on?
Yes, so in terms of building materials, we decided to use mass timber, which is a carbon sequestering material. So that sort of took into the number that you see here, in addition to using concrete, because it is a very structural material, but with the addition of using low carbon concrete. And so in terms of building materials, we were focusing on sort of the low carbon content in that, and then also using locally sourced materials, and such as the Sushuti bond siding, which is a charred siding that also acts as a carbon sequestering material.
Great, thank you.
Thanks, guys. One quick comment and a quick question as well. I think the integration of the data center and the tech and the career pathways is incredibly pertinent in conversations in school districts, today. So nice work bringing those together. And you kind of answered this at the start, but I'd be interested to see the market analysis kind of develop a little more on the availability of this tech and kind of where are we 5 years out? Are we 10 years out? Where do you guys land with
In
that?
terms of the data center tech?
And so yeah, some of the HVAC approach and all of the various components.
Okay.
Yeah, solar pavers, kind of all of those.
Okay. So in terms of the PD products, those are all existing products that we found and implemented. So the PD pavers, I'm going to forget the name of the company, but they're a Hungarian company based, and then they've done, I believe, some work with Habitat for PD pavers. And then the glass is a Chromatics, which I believe is Danish. Yeah, Swiss product. And that has a number of implementations in Europe, I think, right now. In terms of the data center, the tool, do you want to answer that question for the technology?
In terms of immersion cooling systems, this is not something new. Even one of the biggest companies, they are testing this system. It's reliable, it's easy to use, easy to make.
Extras as part of the install or?
Yeah, so I think the paper size itself is about 24 by 24. So I think you can kind of prop it up like you would a normal paper and replace it. So it should be fairly easy if you need to maintain a replacement.
Yes.
Thanks.
Yeah. I don't know if you guys have any questions about the HVAC systems, but I can go ahead and speak on it. Let me pull up my. So we use 4 25-ton distributed outdoor air units, and those feed into an underfloor air distribution system. So we have supply air that comes from the floor and return air that comes from, the ceiling. So we're bringing air up and away from students. So any germs and viral goodies will go up away from the students. And we also have radiant flooring, which helps to heat the air where the students are actually inhabiting. So you're not heating the excess air above them. And it's all liquid. So it's, the radiant flooring is liquid. So it's great other. And each classroom, they're zoned by type, but then each classroom has their own CO2 sensors. So they're only ventilating based on the current occupant demand, but can of course be overridden for uses like this.
Yeah. And I believe all of those are actually used at NREL, so they do exist.
I guess on that note, did you look at NREL and the ESIF in our data center at all?
We looked at it very initially just to kind of get an idea of an efficient data center, but we were not looking at the specific systems. A lot of what we heard yesterday was a weird coincidence. So yeah, we kind of just looked at it as kind of a baseline, but then we're looking at other projects for some of the more detailed items.
Okay. And I like the integration of your green light, your actual classroom participation. Really, it's an innovative way for getting people to acknowledge what needs to happen versus, I know here we just have automated windows, but that's I think a better route to go to get people used to it so they can start doing it at their own houses, etc.
Do you guys remember at the semifinal event, I told you that this looks a lot like a building on NREL's campus? I'm glad you toured it yesterday.
Yes.
I wasn't joking.
Yeah.
All right, we have jurors. We still have about 2.5 minutes for any last minute question if you have them.
I have a non-technical question. So just curious, you said this is I think you said a new identity for an old city, being near Alexandria. How do you think that like the community would respond to having this like degree gap that's needed, but
So actually one of our advisors, Stephen Koenig, is on the Alexandria City Planning Commission, and he has been an amazing advisor for us and is super excited about this. So as you saw, a lot of our kind of background information is based on the existing master plan that they have created, which right now the only kind of set in stone building is the innovation campus, and everything else is just kind of an assumed program, but they're not totally sure yet. So we've had meetings both with Stephen, who was very into the data center idea, and then also Dr. Tricia Jacobs is the director of the career and technical education at Alexandria City Public Schools. So she has given us a lot of background information on how to design the school, and has also been very enthusiastic about kind of the idea of a third campus specifically dedicated to STEAM and CTE training. That's great.
Our conversation with President Jacob, we found a few points that Alexandria was lacking in terms of things they needed, such as our auditorium where amphitheater space for graduations. Currently, they have to use another university outside the city limits to do their graduation. So we're kind of providing a assembly space for the city that you have to have.
Yeah.
That's great. There's a clear gap and need there, just, but it's a very stark contrast. So great that you thought about it.
Did you mention you have a large display on the outside of the building?
Yes.
How does that affect your PUI?
Kathleen, do you have an answer for that?
Yes, can you please repeat the question?
Just curious on your large external building display, how does that affect your EUI?
It brings up the equipment load. I am sorry, I do not have the numbers on me.
I think Kamal also, if Kamal is there, did a calculation.
Sorry, I don't get your question. Please, can you just repeat? Like,
LED screen, did it elevate our EUI, or how did it affect the EUI?
no, I'm sorry.
Yeah, so the LED screen, it did bring up the wattage of the equipment load, so that's how it kind of affected it. But yes.
But we are still meeting our energy.
I would also like to add that that north facade is it's Route 1. It's one of the main ways you get into Alexandria from DC. So we kind of used it as a billboard for the city of Alexandria, like any community events. So we wanted that specific view to have a lot of visibility.
Fantastic. Thank you, jurors. That wraps up our 15 minutes Q&A. Thank you to our team from Virginia Polytech and those that participated virtually. Round of applause again. Thank you. Okay, we are now on here in the Mountain West, we are on a lunch break. So we're going to break for about, 1 hour. After lunch, our first team is going to start at, where am I? We're going to start with the University of Cincinnati at 3:30 p.m. Eastern time. That's 1:30 p.m. local time. So